So we're going to start looking at contingency tables for probability, and this might be revision for you from years past, but we'll take a look at it with a new light as well. So tables are just nice ways to display data, especially if you've been collecting survey information, things like that are categorized. Often the information inside the tables will represent people, or in this case dogs, or just the numbers of responses to a certain number of questions, or number of individuals that fall into certain categories. You want to add the totals to the edges of the table if they've not been given to you. They'll be very important to use. And we want to remember that our basic formula for probability is always just the desired number out of the total number. And sometimes highlighters can be helpful. So let's just put it into practice. This problem, dogs out for a walk on the beach were asked questions about fetching sticks and obeying the stay command. The results are included in the table below. So I've got a table that shows me dogs that stayed when they were asked, dogs that did not stay, dogs that fetch sticks, and dogs that do not fetch sticks. And I notice here immediately that I'm missing my totals. So I'm going to go ahead and add that to my table. And what I mean by that is I'm going to add up how many go into each row and column. So for instance, if I want to know how many dogs in total fetch sticks, I need to add the 38 and the 46 because everything in that row, everything in this row, are dogs that did not fetch sticks. So 38 plus 46, we get a total of 84 that do not fetch sticks. Sorry, fetch sticks. For don't fetch sticks, we're going to add 14 and 82, and you'll get 96. And same we want to add vertically here, so the total number of dogs that stay when asked would be 38 and 14. Adding those together, you'll get 52. And the ones that don't stay, 46 and 82, you get 128. So we get our totals across the rows and across the columns, and then we want to know how many total dogs were surveyed here on the beach. So this way you can either add up 84 and 96, or you can add up 152 and 128. That'd be 180 total. And you don't want to add everything along the row and the column and get double that. You just want to add one way or the other. And that 180 should also add up to everybody inside the table that you were given originally. So 38 plus 46 plus 14 plus 82 should give you 180 dogs. Now that we've got our totals, let's think about finding our probabilities. So find the probability that a dog chosen at random on the beach, so there's 180 dogs on the beach today that have been surveyed. What's the probability one of them will fetch a stick? So I need to know how many will fetch a stick. Well, I know that 38 will fetch a stick and stay, and 46 will fetch a stick and not stay, but I'm looking for the total number that fetch a stick, so that is just going to be 84. So 84 total dogs out of 180 total dogs. And you can leave your answers as fractions. It's quite a nice way to do it, but if you wanted to, you can also round it to 4dp, plug it into your calculator, 84 over 180. You get 0.4667. Looking at the next question then, number 2, what's the probability that a dog doesn't stay or don't stay when asked if we pulled one randomly out? So I need to know how many dogs do not stay when they're asked. And so I need to know the total number of dogs that don't stay, so I'd look to the total number at the bottom. So 128 total do not stay when they're asked to stay. So 128 out of 180. And again, that's out of the 180 total, and we can write that as our decimal, 0.7111. For number 3, what's our probability that a dog randomly selected off the beach will fetch a stick and stay when asked? So if we're looking for fetching a stick and staying when asked, we need to think about, well, two things. They've got to be able to fetch the stick and stay. So fetching the stick and staying, that's just those 38 dogs there. So there's only 38 dogs that will fetch the stick and stay. So we're going to have just the 38 out of the 180. And 38 divided by 180 gives us a decimal, 0.2111. Okay. Number 4, we're looking for dogs that don't fetch sticks and stay when asked. So in this category, I need to figure out which ones do not fetch sticks and stay when asked. So I see that 14 will stay, and 82 of them won't stay, so I'm looking for those 14 that will stay and do not fetch sticks. So that's going to be a total of 14 that I want here out of the 180 total. So that's our basics for the tables. I'm going to come back to these two asterisk problems in another video shortly. Just to keep it simple, gone through some of the basics, and we'll just build on this, and I'll come back to doing those conditional probability ones, although you may remember them from before.